and welcome to our video on section 6.4, Solving by Factoring, using the zero product property. First thing we're going to do is we're going to try to find some solutions for when we have the product of two, in this case, variables, a times b equals 12. And we're going to think about the fact that if we have an equation such as a times b equal 12, the solutions are going to be factors of 12. So for example, we could think of a being 1 and b being 12. Or another combination might be, well, what if a was 3? Then b would have to be 4. And again, continuing in that vein, we could say, well, okay, what if a was 2? Then b would have to be 6. And all of those would be considered factors of 12. Next, let's look at the same equation, but instead of being equal to 12, we want to say what happens if a times b is equal to 0? Well, using the same idea, we could think about a times b, and we could think, well, what if a was 1? Well, if a was 1 and we wanted it to equal 0, the product, then b would have to be equal to 0. Let's try another one. If we have a times b and a is 3, then b, by definition, would also have to be 0 in order for the product to equal 0. And if a was instead 2, then b would have to be 0. So no matter what we make a, b would have to be 0 for the product to equal 0. Now we could have reversed and given numbers for b, and then a would have to be 0. But the important thing is to recognize that if the product of two factors equals 0, then one or the other factor must be 0. So let's see how that works with some examples. If we have a question mark, meaning we don't know the number, times 1.08 equals 0, well, we know then that the question mark would have to equal 0. If we have 5 times, and in this case we have a parentheses, so we have a quantity, question mark minus 4, well, the parentheses has to be equal to 0. So what number, if we plug in for the question mark, would make the parentheses 0? Positive 4 would make the parentheses 0. So the question mark here would have to be equal to 4. One more example, we're going to look at C, which notice we have two factors in what we call factored form. So x minus 2 is a factor and x plus 3 is a factor. X minus 2 is like our a term, and x plus 3 is like our b term that we were looking at above. Now remember, one or both of the factors must equal 0 for the property to work. So either x minus 2 equals 0 or x plus 3 equals 0. So when we solve here, we could just add 2 to both sides to get x is equal to 2. That would be one of our possibilities. Or here we would subtract 3 to solve for x and get x equals negative 3. So let's just go ahead and see how that makes it true. If x is equal to 2, then I'm going to get 2 minus 2 in the first parentheses, and the second parentheses is going to be 2 plus 3. Well, I'm going to get 0 times 5, which does equal 0. So that one would work. Well, what if instead we had x is equal to negative 3? Would that also make it true? So in that case, we're replacing the x with negative 3. So negative 3 minus 2 would be our first parentheses. And our second parentheses would be negative 3 plus 3. Well, our first parentheses would come out to a negative 5, and our second parentheses would come out to a 0. So again, negative 5 times 0 does equal 0, so that would make it true. All right, so now that we've introduced what's called the zero product property, let's see how it works in action with an actual quadratic equation. So we're going to look at number 4 where it says, so if we are trying to solve an equation with a product that equals 0, we know that at least one of the factors must be 0. What do we do if the equation is not written as a product? Well, that's where all of our factoring skills from Unit 5 will come into play. So here I have a quadratic x squared plus x minus 12 equals 0. And what I'm going to use is our crisscross AC method. And I'm going to say what multiplies to negative 12 and adds to 1. And hopefully you're thinking, oh, positive 4 and negative 3. Which means that I can go ahead and factor to x plus 4 times the quantity of x minus 3. So this is in factored form, and we have a product of two factors. X plus 4 is a factor, and x minus 3 is a factor. To solve, we would simply take each of those factors and set them equal to 0. And we've already solved this one. No, we did not solve this one. So we would simply do a quick solving by subtracting 4 from both sides to get x equals negative 4. And here we would add 3 to both sides to get x equals positive 3. Both of those numbers would make the equation true. So let's take that example and see what would happen if we graph that in our calculator. So I've gone ahead and taken the equation, plugged it into my calculator, and put the graph here for us to look at. So as you can see, the x-intercepts where it crosses the x-axis are at positive 3 and negative 4. So that means that we could write those as ordered pairs, negative 4 comma 0 and 3 comma 0. That's where this graph crosses the x-axis. Notice that the y-coordinate for both of those is 0. By definition, when we cross the x-axis, the y value is 0. So if we're solving y equals x squared plus x minus 12, then we know that in order to solve it, we're going to change the y to 0, just like we did above, so that we can find the x-intercepts. Okay, so I'm just going to write a few quick notes to summarize what we've discussed. And the first is just saying what the zero product property is. Zero product property. And that is simply stating that when we have two factors being multiplied and set equal to 0, that one or both of the factors must be equal to 0. Next, we looked at solving by factoring. And to solve by factoring, what we want to do is always make sure that we rewrite the equation set equal to 0. The zero product property only works if we're set equal to 0. What that means is that we're in standard form. And standard form is when we go from the squared term to the linear term to the constant. Next, we're going to factor and then set each factor to 0. To solve, just as we did in the last example. And then just to make the connection, I want to write that x-intercepts, they are solutions, or roots, we sometimes call them, roots, when y equals 0. Okay, so those are our notes. I have some practice problems. In particular, I'm not going to do the graph in the first one. I'm going to just go through some practice problems in number 2, just to make the video a little bit shorter for you, just to emphasize some of the problems that you might get. So in solving something like A, we see that we're already in factored form. What I want to point out in this example is that we have the factor -5, we have the factor 2x minus 3, and we have the factor of x plus 4. However, because -5 is a GCF or a number, it is not going to result in a solution because a number cannot be equal to 0. So that will not affect the answers or the solutions that we have. What we will have are two answers from 2x minus 3 equals 0 and x plus 4 equals 0. And in particular, I'm going to move this one over so I can give myself a little bit more space. When we have something like 2x minus 3 equals 0, it's going to involve 2 steps instead of 1 step. We're going to add 3 to both sides of the equation, and then we're going to need to divide both sides by 2. So I guess what I want you to know from this example is that if you have a coefficient or a number in front of the x, you will end up with a fraction, and that's okay. The second factor, the x plus 4, is much easier to solve because we're just going to be subtracting 4 from both sides. So our two answers are 3/2, or 1.5, and -4. All right, our second example that I wanted to show you is example B, and that's because this one's a little different in that it's not a crisscross problem. So remember, you would need a trinomial to use a crisscross, and our first step in factoring is always a GCF. So here we actually have a GCF of 6x, and if we take that out, the 6x, we're left with the quantity of x minus 9. What I want you to know here is that there are still two factors. 6x is a factor and x minus 9 is a factor. We don't want to forget to set 6x equal to 0 to get one of our solutions. And then our other solution will come from the quantity of x minus 9 equals 0. Now here, if we solve for 6x, we would divide both sides by 6. And 0 divided by anything is still 0. So 0 is one of our answers. And then here we would just add 9 to both sides to get our second answer, which is x is equal to 9. So hopefully you're noticing that quadratics almost always have two answers. Our last example is to show you the importance of putting an equation into standard form. We cannot do our crisscross until we subtract 3 from both sides. And this is already in standard form because it goes from x squared to 8x, and then our constant, which after we subtract the 3 is going to be a positive 15. Now we're set equal to 0, and now is when we can do our crisscross. So what multiplies to 15 and adds to 8, hopefully we're thinking 5 times 3. And again, I'm not doing one where we have to split the middle term here, but we would get x plus 5 as one of our factors and x plus 3 as another factor. Setting each factor equal to 0 and then solving from there, we're going to get -5 and -3 for our two solutions. This concludes our video. Please bring any questions to class with you.